I'm going to do for you an example. I won't solve it though, rather I'll give you the solution and show you what that solution is trying to tell you. Again, the function is periodic. It's a square wave. It's minus 1 from minus pi to 0, and it's 1 from 0 to pi. It's a function of time, f of t. And to write this square wave in terms of complex Fourier series, I have to have complex coefficients, cn's. And for that you have to solve this integral for this function. And once you do it, it will turn out to be minus 2i divided by pi n, where n has to be plus or minus 1, plus or minus 3, plus or minus 5, and it will move forward. Just odd frequencies. And by the way, these cn's, since you see I here under root of minus 1, it has to do with the complex numbers. The cn's are going to give you different points in the complex plane for the different values of n. That's what it does for you. Now you have cn's, I can write this function, its Fourier series, f of t will be the summation over n's, which goes from minus infinity to infinity, cn's minus 2i divided by pi n times exponentials e to the I and t. And this is it. This is the solution for this function. Now, if you have the patience, I want to expand it, and then I will show you how this sum represents this function. So I will take 2 over pi outside, and I'm coming from minus infinity, but I will start with minus 5. When I put n equals minus 5 here and here, minus times minus gives you plus, so it will be I over 5 times e to the minus I 5t. When I take n equals minus 3, I get I over 3 times e to the minus I 3t. N equals minus 1, I get plus I times e to the minus it. Now when I take positive numbers, n equals 1, I get my minus sign, so it will be minus I times e to the it. Now plus 3, I get minus I over 3 times e to the I 3t. Then you will have a minus sign, and you will have next terms, many terms. So it's an infinite number of terms that you get here. It's a sum. And these exponentials are your rotating vectors in the complex plane. And as the time passes by, you are going to see circles because they are going to rotate, and they create sort of circles. And I want to draw those vectors. And so I will start with this one. This is a rotating vector in the complex plane. So let me make you the complex plane. This will be real axis, and this will be imaginary. And here is a 1, and you get 2, 3, 4. And for this imaginary, it could be I, 2i, 3i, and downstairs you will have minus I, minus 2i. Now, where should I put that vector? Should I put it right here like this, or right here? Where should I put it? Well, it's better if I could know where that vector is at time t equals 0, because then I can put t equals 0 and you get e to the 0, which is 1. So this exponential goes away and all you are left with I. And since it comes from Cn's, this gives you a point in the complex plane. And so this I represents a point that you're going to have is at this mark, at mark I. Or the vector to that point is right there at time t equals 0. And as the time passes by, it's going to rotate with negative frequency, -1. And negative frequency means go clockwise. So it will go clockwise like this. And by the way, the magnitude of this vector is 1. Now, what about these ones? At time t equals 0, you get I over 3, 3 times shorter. The direction of the vector will still be the same, but it will be 3 times shorter, and it will go clockwise with a frequency -3. -3, it will tell you these are higher harmonics. So this one will go 3 times faster than that. This one at time t equals 0, this is I over 5. So this will be 5 times shorter and it will go clockwise, but 5 times faster than that. And then you will have here next terms, those rotating vectors that you're going to have, they will get shorter, they will become shorter and shorter, but they will go around faster and faster. Now this is all about negative frequencies. What about positive ones? Well, at time t equals 0, this goes away and all you are left with -I. And in the complex plane, the -I is somewhere here, means the vector is right there at time t equals 0. Now it's going to go around with positive frequency. Positive means go counterclockwise. It will rotate like this. And now you can guess it for this one, it will be 3 times shorter, will go counterclockwise, but 3 times faster. And then you will have next terms here, the other vectors that you're going to get. And this is a summation. Now you have to add them all up. And then this is a vector addition. You take the head of one and you put on the tail of other. That's how you add vectors. And they are going to dance around. And somehow they represent a square wave as a function of time. I will show you how it does that, how it represents that square wave. But before that, I want to write this I a little differently. Because it comes from Cns, and Cns are doing two things for you. They give you the size of the vector. Like here, the size of the vector is 1. The magnitude of that is 1. And it gives you the second thing, that is the phase of the vector. It gives you where the vector is at time t equals 0, where it will start off from at time t equals 0. So I want to write this I a little differently. It will still tell you the size of the vector and still the phase of the vector, but it will tell you the phase in terms of angle, phase angle. And so I will take this I, so I take this I, and if you allow me, I want to add 0. Nothing has changed. But now I can write this as cosine of pi over 2. And this one has I times sine of pi over 2. Still the same thing. But now Euler says it has to be e to the I pi over 2. Euler's formula. And this is the angle. It means you can replace I by this e to the I pi over 2, and this gives you the phase angle. And you can see the phase for this one, phi is pi over 2. This is where the vector is at time t equals 0. It is at angle pi over 2. And for this you can say it, you can guess it, it must be minus pi over 2. It's at that angle. It's going to rotate like this. Maybe you didn't want to start off at 90 degrees. Maybe you wanted to start with at 45 degrees, pi over 4. So this will be your imaginary axis. If you want to do that, if you want to start it off at 45 degrees angle at time t equals 0, what then? If the size of the vector is 1, like I had in this case, then this point is going to be, or you can decompose this vector, this component will be 0.70, and this component will be again 0.70, and then this quantity will be cosine of pi over 4, 45 degrees, and this will be sine of pi over 4. And now Euler says it has to be e to the I times pi over 4. What I want to do is, if this I had been this quantity that you see here, if this had been this, you could have written this as e to the I pi over 4. And pi over 4 tells you at what angle the vector is going to start off from at time t equals 0. That's what it tells you. So this vector would have been here at time t equals 0 if this I had been this quantity. So that's how you can check where the vector is in terms of angles. And now I want to show you how these rotating vector, when they combine together, give you a square wave as a function of time. And so negative frequencies start off from the phase angle pi over 2, and positive frequencies at minus pi over 2. Let them go at time t equals 0. They go clockwise, they go counterclockwise. This vector is 3 times shorter than that, 5 times shorter, and the next ones will be 7 times shorter, 9 times shorter. But going around 3 times faster, 5 times faster than the fundamental. And the same goes for negative frequencies, rad vectors. First, I'm going to add these two vectors together to show you what it looks like in the complex plane. Then I will add these 4 together and then more to show you what happens. So take the tail of that and put on the head of that. That's how you add vectors. And if you are ready, that's what it's going to look like in the complex plane. If you allow me, now I want to add 4 vectors together, head to tail. This is how they dance around. And this black dot is on the head of the last vector. And if I add 10 vectors together now, this is how they go crazy. They go nuts. And notice this black dot wants to stay near 1 half of the time, and half of the time it wants to stay minus 1. And now if I add almost like 40 terms, 40 vectors, It comes very close, and then all of a sudden it jumps to -1, then comes to +1 all of a sudden. And now, if you show this as a function of time, you plot it, it produces the square wave. It is a square wave. I've got you one more example. A few things are important. You change them, everything changes. First, the size of the vector. Second, the phase angle. Third, which frequencies harmonics are participating. This time, this vector is 9 times shorter. The next one will be 25 times shorter than the fundamental. And all of them will have the same phase angle. It doesn't matter whether you are negative frequency or positive frequency. But this time, this is not going to rotate. This term, this vector, comes from coefficient C0, frequency 0. It's not going to rotate. Or you can say it differently, to go around once and back here, it's going to take infinite amount of time because frequency is 0. It's frozen in time. Add them all up, that's what you see. And as a function of time, you get triangular wave.